Welcome to video tutorial channel of mekanizmalar. The pelton turbine is invented by Lester Allen Pelton in the 1870s. It was the first time the energy in the water converted to power in most efficient manner. Due to its simplicity, the pelton turbine is the most widely used water turbine in the world. Pelton wheels are the preferred turbine for hydropower, when the available water source has relatively high hydraulic head at low flow rates. The efficiency of this turbines increases with water head. There are 200 megawatt pelton turbines in operation where water head exceeds 1000 meters. Small pelton turbines with enough water flow can operate as low as 15-meter water head. Pelton turbine converts the potential energy in water to kinetic energy in the nozzle. Therefore they are impulse-type turbines, which the water strikes the turbine blades with high velocity. For example, for the water head of 1000 meter, the jet velocity coming from the nozzle could be 135 meter per second. Here is an actual wheel of a pelton turbine which is almost has 2 meter diameter. The spoon-shaped buckets shown in here are bolted to the main discs of the wheel. The buckets are designed in such a way that it splits the water jet into two parts, and each part of the jet make a U-turn in both sides of the wheel. Also notice the tip of the buckets, where a round open section, combined with the groove at the back of the bucket, allows the water to strike the right bucket to produce maximum power. The buckets of these kind turbines could be as much as 150 kg. Assuming that the average wheel has 20 buckets, the total weight of the buckets around the rim of the wheel reaches to 3 tons. This makes whole wheel act like a very large flywheel. Since the water head is fixed, the power output of the turbine is controlled by adjusting volumetric rate of water. In the pelton turbine this is accomplished by moving the spear, or sometimes called the needle, back and forth by a servo mechanism. Notice that how the diameters of the water jet get smaller or larger depending on the position of the spear. If flow rate goes to 0, the wheel keep turning such a long time due to flywheel effect generated by heavy buckets. To prevent the wheel rotating such a long time, braking flow is used. A small water jet is sent to the back of the buckets to break the rotation of the wheel. If there is sudden power rejection in the system, needle may not have enough time to adjust the position to reduce the amount of water flow. This causes the wheel to begin to turn almost twice the regular rotation speed, which could be dangerous for the operation of the turbine. To prevent this, system senses increased speed and activates deflector mechanism to deflect the water to discharge pipe and prevent the turbine from damage. We encourage you to subscribe to our channel and give a thumb up to our video. Thank you.